In this video, I am going to be talking about three C++ topics: class template, template instantiation, and class instantiation. I will begin by explaining class template first. I am going to be using this editor to explain class templates. The code I have here is the main function with two arrays, height and mark. Height holds integer type data items. Height is centimeters and marks is the marks of the person or student in percentage. Right. So template is a class which allows you to represent different kind of data. In this case, if I want to have a class to manage either int type array or double type array depending on our requirement, then I can create a template class as follows. To create a template class, you need to use a keyword called template and followed by angle bracket. Inside angle bracket, you specify type parameter. The way you specify type parameter is you use the keyword type name and the name of the parameter. It could be T, it could be U, whatever you want. You can also have multiple letters here, right? I'm going to use only single letter in this case. Now followed by keyword class, because we are creating a class template, and the name of the class. If I want this class to manage the arrays, then I would use the keyword, the word array as the name of the class. I can use this array because this is not the keyword used in C++ library, so it's okay to use it. If I want to manage an array of either integer or double type, then the type of that array is going to be this T, because T is actually you can consider this as a placeholder for the type that is going to be used, right? If this array is this class is going to be used with for integer type, then T will be replaced by integer int. If this class is going to be used for double type, then T is going to be replaced by double, right? Therefore, the type of the array I'm going to define here is going to be T followed by name of the array and 100. This is the capacity or the maximum possible elements you can store in this array. We also need to keep track of the size, total number of valid elements that are currently stored in this array. I'm going to use this name for this. This is essentially going to be the size of the array. Now I also want to keep a record of the capacity of the array, which is going to be the total number of elements you can store, 100. Let me create few functions to actually manage this data, because all these things are private, so we need a function to enable access to this data. So default constructor first. By default, we assume that number of elements is 0 in the beginning, and capacity is going to be, let's say, 100. Now, if I want to actually create this array by copying element from another array, then I need to have a custom constructor. The element I'm going to receive is going to be of same type, because if this array is going to be used for int, so it will be instantiated for int type. So the type this custom constructor will receive type of the element of the array. This function is going to receive is going to be same as the type parameter. So I'm going to have type, because I want to receive an array, so constant T pointer, name array, then size, right? Now first I would like to make sure that all the elements, these attributes, are initialized to default value. So I would like to invoke default constructor in this case. So this will actually make sure that first these are initialized to default value, particularly this element, this data is initialized. Then after that I would like to do a validation of incoming data. Array pointer is valid and size is positive. In that case I can use a loop size I plus plus, and also I don't want in the case where the size of incoming data is longer than or bigger than 100, then I don't want to copy elements more than 100 because this array does not have that capacity. Therefore let me put another condition here. I less than 100. Then we can copy element by element. And before that I would like to also copy the size in, and if I have already copied, then it's better to use that attribute variable than the incoming variable. So I think this is the complete custom constructor in this case. In addition to that, I also want to if I create an instance of object of this array, then I want to be able to use the indexing operator or bracket operator. For example, if I create IARR function, then I should be able to use this operator to access the second element, right? So for that we need to overload. We need to have overloaded version of this operator, and the parameter is the index. It returns x, right? And the return type is going to be because the type of element is t, so it's going to be t, and we want to return by reference because if we don't put reference in this case, then we will not be able to copy any data, right? So if you want to enable writing into it, then you should return by reference. Now one more thing I want here is I want to know this capacity. This private memory is not accessible from the outside the class, so we need to have a function that returns this the value, the data carried by this attribute. So return type int size, and we want to make it query because this function does not make any changes to the attributes. Now size function defined. With this we should be able to use this template. This is a template, right? Now if I want to use this template to manage int type array, then I will have to write an instruction, a statement asking the compiler to instantiate, to make use of this template. So the syntax for doing that is, first you write the name of the template class followed by angle brackets. Here you have the name of the array object, and if you want to create object by invoking default constructor, just leave like this. If you want to create object by invoking this custom constructor, then you need to pass array and size. So in this case I'm passing heights array, and the size of height array is 10. Now since we are using height array whose element type is integer, so we need to specify type parameter. this actually tells compiler what this type parameter should get. In this case, integer type. So it would replace this t with integer, this t with integer, right, and this t with integer, right. So now we have object created and object is initialized to this data. I want to actually display the data, right. To display data, the thing is that we will have to use this two functions. The usefulness of these two functions will come up because we want to iterate up to this elements and we want to access each element using this function. So let me do that. Let us do it. We can get size by calling size function and I++, and we want to access the element by using this operator. Right, so let's see how it works. Before that, I also would like to, after this is printed, I would like to make changes to one particular element, because just to demonstrate that this return by reference actually works. I am making change to this element 173 index 2 equals to, let me make it 999, right. And after that I also want to print the array again, right. So it will make change and it will display again, right. So just to see whether that change actually happens or not, let me compile this code. I hope there is no problem. Looks like there was a small issue here. So ITUR returns, sorry, return. I think this was the problem. Let me try to compile again. So now you can see the output. First, the data is displayed. All this data 160 to 140, all this displayed, and we made changes. We actually copied 999 to this element and it was changed. Okay, so it is working as we expected. So this was the outcome. Let me also experiment with for the double type data. So I'm gonna make change into double and change this name marks double and use double type. So all the changes have been made. If we try to compile, I think it should, I hope there is no problem. Let me compile it and show you the output. Right, so you can see the output. The output one, 2, 3, 4, 5, 6, 7, 8, 9. I told 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 data. Out of 10 data, the third one is actually changed to 99.9. So it's working, you can see. Now I'm going to be talking a little bit about template instantiation and class instantiation together. For a templated class, this code, the code for instantiating the template, essentially tells the compiler to instantiate this template class and create a concrete class with the type parameter t replaced by integer int. So this is essentially a class that is going to be used. This template class is just a template. It is something that is not going to be used. Once it is the concrete class is created by replacing the type parameter by the desired type, that is the class which is going to be used. Again, in the case of double instantiation, this will tell compiler to instantiate the template class to create another class with a double type. So with this instantiated version of the class on the top right, once it is created, instantiated, then this statement further tells compiler to use this instantiated version of the class to create an object ARRI by invoking the custom constructor. So it has two things happening. First, this first part of this statement will tell compiler to instantiate the template class to create a class, concrete class, and afterwards that concrete class is going to be used to create an object called ARRI. Now, in this case, in the previous case we had this first statement for the template instantiation. The second statement, in the second statement, the first part of the second statement was already executed in the previous statement, right? This statement for instantiating the template to create a class. So that action does not take place in this time because the class has already been created by the compiler. Compiler will use the already created class to create this object. Therefore, this statement actually only tells, it doesn't tell compiler to instantiate the template to create concrete class, but it tells compiler to use the previously created concrete class to instantiate or to create an object. Right now, I'm going to be talking about the benefit that the use of template can bring in the code. But before that, I'd like to bring your attention to the fact that template instantiation and class instantiation, I told template instantiation is actually the use of template class to create a concrete class by replacing the type parameter by the parameter of interest, type of interest. In the case of class instantiation, it is the use of the created class out of the template to create an object. Now, coming back to this discussion, since we have this code, as when the compiler scans this code, when it comes across the use of this instantiation instruction, then it actually creates one version of the class, and when it comes across another instantiation with different type, it creates another version of the class. So it has two versions of the class created, one for integer type, another for double type. Now, the advantage, ideally you would have to write this code and this code together in your program, but the benefit the template gives us is you can, instead of writing the code for integer type and for double type, or class for integer type data and for double type data, it allows you to write a single code, right? That will help you to minimize the amount of code you can have in your source code, right? and also it has several other advantages. The end of this video.